The last 3 to 4 years, we have seen a tremendous growth in the e-bike industry. We have seen hundreds of e-bike brands come up, and as a result, we have hundreds of different kinds of batteries being used. Now, the safety of your electric bike is directly connected to the battery, and the way you charge your battery pack is very important. So in this video, we're going to learn about e-bike chargers. In this video, we're going to learn about how e-bike charging works, what is a fast charger, what is a smart charger, and what you should look for in a good e-bike charger. I'm Ravi Kempaya. Welcome to Zen Electric Bikes. So in its most fundamental form, e-bike charger is a device that takes the AC power from your wall outlet, converts that to the DC power needed to charge your battery pack. The AC wall outlets range in voltages across the world, whether it is 120 in North America or 240. We take that voltage, we have to step it down to 36 or 48 or 52 volts needed for your e-bike battery pack. Now, most e-bike battery packs are made of cylindrical cells, 18650 or 21700. To really understand how the charging works, we need to understand what is a nominal voltage and what is a fully charged voltage for these battery packs. Let's take a look. Now, whether it is 18650 or 21700 cells, the nominal voltage is 3.6 volts. When you fully charge them, it goes to 4.2 volts per cell. To get the desired voltage and capacity for your e-bike battery, we connect these cells in series and parallel groups to get the right kind of voltage and capacity. For example, a 10S battery pack means these cylindrical cells are connected in series, 10 of them connected in series. So 10 multiplied by the nominal voltage, which is 3.6, gives you 36 volts. Similarly, 13S battery pack, 13 of these cells are connected in series, some in parallel. 13 multiplied by nominal voltage, which is 3.6, gives you 46.8. Now this 46.8 is rounded off to 48 volts. That is the nomenclature everybody uses. Now 13 fully charged voltage is 4.2, gives you 54.6. So the fully charged voltage of a 48 volt battery pack is 54.6. Similarly, 14S pack, 14 multiplied by 3.6 is 50.4, which is rounded off to 52 volt pack. Now, when you fully charge this, 14 multiplied by 4.2, which gives you 58.8 volts. So the fully charged voltages for 10S, 13S and 14S are 42, 54.6, 58.8. And that is exactly what you see on the back side of your e-bike chargers. If you look carefully, you will see either 42 volts or 54.6 or 58.8 volts. So now we know what is a nominal voltage, what is a fully charged voltage. We know what is 10S pack, whether it's 36 or 48 for 13S or 52 volts for 14S packs. So we know the nominal voltages, we know the fully charged voltages. Let's see how the charging really works. What is the mechanism? What is the protocol? So how exactly this charging works? Most e-bike chargers are based on this charging protocol called CC-CV. Now, what is CC-CV? CC stands for constant current, CV stands for constant voltage. Why do we need to follow this protocol? Let's take a look. To really understand it, I'll give you an example. Imagine a long, 2-kilometer long freight train with thousands of containers, okay? You have this train moving at 150 kilometers an hour. How long does it take to stop this train? So it's moving at 150 kilometers an hour. It takes at least 3 to 4 kilometers before it can come to a proper stop, right? Same thing in the e-bike battery or in any battery. There are millions of lithium ions going from cathode to anode. To really safely complete this process, we need to follow this protocol. Now, what is happening in this protocol? Let's take a look. So in the constant current mode, millions of these lithium ions are shuttled from cathode to anode, cathode to anode. So the bulk of the charging happens in this constant current mode. So the current is kept constant, the voltage keeps raising. Once the voltage hits 4.2 volts per cell or nearby, close to 4.2 volts per cell, what we do is we slowly start reducing the current. The voltage is kept constant. So the voltage is kept closer to 4.2 and slowly you reduce the current. This is called the CV mode. But the bulk of the charging happens in the CC. Now, if the bulk of the charging happens in the CC, why do we need CV mode? So to explain why we need the CV mode, let me give you a quick example. Imagine you're pouring water into this big mug. In the beginning, you're pouring a lot, but as you get closer to the top, you reduce the rate of pouring, right? Same thing. In the e-bike battery, initially it is constant current. To reduce sort of overspilling, you slowly reduce the current, which is a CV mode. So by the end of CC and CV, you have shuttled most of the lithium ions from cathode to anode. And this completes the charging process. So as you see from the graphics, all the cells have gone from nominal 3.6 volts per cell to 4.2, and constant current, constant voltage, this protocol has been followed, and by the end of it, all the cells have reached their full charged voltage of 4.2. And this is what we want. That means at the end of it, the battery is fully charged. So now we know how this CC-CV protocol works. We can take a look at charging currents, because ultimately it is the charging current that dictates the rate at which you can fill up your battery pack. How fast you can charge your battery pack, it is dictated by the charging current. Now, most of the e-bike chargers on the market are 2 amp chargers. So if your battery pack is 14 amp hours, 14 divided by 2 is 7 hours. It takes 7 hours to completely charge your battery pack. If you have an 18 amp hour pack, 18 divided by 2, that's 9 hours. So it's a pretty long, duration of charging. So 2 amp is considered slow charger, and to reduce the cost, many e-bike manufacturers use this 2 amp chargers. What we find is that 4 amp is a middle ground, sweet middle ground. Let me explain why. Imagine you have a 14 amp hour pack, you're using a 4 amp charger. It takes about 3.5 hours to fully charge your battery pack, which is reasonable. Or even if you have about 16 amp hour pack, it takes only about 4 hours to fully charge your battery pack, which is reasonable. Now, there are 6 amp and 8 amp chargers, which are called fast chargers. Okay, 2 amp is slow, sweet middle ground is 4, we have 6 and 8. We recommend you exercise caution when you use 6 or 8 amp hour chargers, because most of the battery packs, battery management system, BMS, is not rated to handle 8 amps. Most of the BMS systems on the market are rated for 5 amps. So this is why we recommend you take caution, especially when you're using fast chargers. It is not to say that you cannot fast charge it. If the BMS is ready to accept up to 10 amps, you can easily fast charge. But the fast charge has some limitations as well as advantages. So what are these advantages and disadvantages? Imagine you're running a fleet of food delivery bikes. Uber Eats, DoorDash, Skip the Dishes. Now, time is money for them. So they don't want to be sitting and waiting for the battery pack to charge. In those instances, fast charging can be very beneficial. Now, what is the disadvantage here? If the battery pack is not designed to handle 8 amps of fast charging current, this fast charging can heat up the elements, can damage the cells, and in the long term, the chemistry may degrade faster. So there are pros and cons to both. So we recommend, if you don't know what you're getting into, and if you don't have the real need for fast charging, stick with something 5 amps or less based on the manufacturer's recommendation. As we described in the beginning, Fundamentally, e-bike chargers are taking this 120 volts or 240 volts from the AC outlet, stepping it down to 54.6 or 58.8 volts needed to charge your battery pack. This conversion involves the usage of inverter circuit with resistors, capacitors, and the process generates heat. Dissipation of this heat is important to keep the charger in good condition. So you will find that some chargers have a fan built in just to promote convection and air cooling, which is good. In our experience, a poorly designed charger with this fan can be a little bit noisy and the charger may not last a long time, the fans may die. But a good quality charger with the right fan, with the right cooling system will last a long time. Now, there are some other designs where the metallic shell of the charger or the casing itself is used as a heat sink. These are fanless chargers, which is good because you don't have any noise coming out of this, but just that it gets a little bit warmer than the fan designed chargers. So in this picture, what you're seeing is a fanless design charger where the casing itself acts as a heat sink. And most of these fanless designs don't go more than 4 to 5 amps because above that you definitely need some kind of cooling to keep it under a certain temperature range. So you will notice different kinds of connectors on e-bike chargers. Let's take a moment to understand what these different connectors are so you know that what to use for your e-bike battery pack and you don't get into any trouble later on. So one of the most frequently used connector on e-bike chargers is the DC 2.1 barrel plug. This is made of a impact resistant polycarbonate with silver coated copper terminals in the shape of a barrel, small barrel, right? This is good for up to 2 amps and that's what you find in most of the 2 amp chargers, but you would really not want to use it for anything more than 2 amps. To handle larger currents, there are different connectors. So XT60 and XT90, these are connectors that can handle currents up to 70 amps or more, and these are 3.5 mm bullet connectors, gold plated. They're fairly robust. These are used in the discharge terminal of many factory built e-bikes. This is what you find in the DIY community as well. And to handle even higher currents, there are Anderson SP connectors. Anderson SP connectors are found in golf cart battery packs, electric boat battery packs, fairly high currents up to 100 amps or more. Maybe you can even go up to 250 amps. But the problem is they're very bulky. They're not really suitable for e-bikes. Maybe electric mopeds kind of an application, they're okay. Now, there are 3-pin connectors, for example, Reintion 3-pin or ST 3-pin or XLR. In this 3-pin configuration, there's a positive and a ground. The 3rd pin is typically used for communicating with the battery management system or some kind of a data. In the case of XLR, the 3rd pin is typically used for thermistors if there is one. So these 3-pin connectors are also found in many battery packs, can handle up to 5 to 8 amps easily, no problem. Let's take a look at smart chargers, because smart chargers can help improve the longevity of your battery packs. What exactly is a smart charger? Smart charger, what it does is, you take the connector, connect it to your battery pack. Now, the charger communicates with the battery management system in your battery. This is typically done over CAN bus protocol. And once it communicates, the BMS checks, okay, if the voltage is okay, if the temperature is okay, if any of the modules are faulty. Once everything is okay from the BMS, then the signal goes back to the charger and the charging starts. This prevents any kind of electrical hazard. And if the temperature is really low, which is the case in Scandinavian countries, Canada, and upper parts of the US, so in that case, the BMS communicates to the charger, hey, the temperature is really low. Based on that information, the charger changes the charging current, because you don't want to charge at low temperatures. using high currents. That will damage the cells. Low temperature, high current is a recipe for electroplating inside the cells, which is not good. So when the temperature information is sent to the charger, it can change some of the parameters. This back and forth communication is what makes the charger smart charger. Okay, and if you look at the connectors, typically there'll be a couple of pins allocated for power, couple of other pins allocated for communication. And if you look at this Rosenberger charging connector, you will see there are 2 pins for power, 4 pins for data. So you can communicate about voltage, current, temperature, all kinds of stuff, which is really important, especially if you're dealing with high power systems, high energy battery pack systems. It's really important there are protections built into the charger and the BMS, so the overall system is really safe. And this smart communication is what sets the charger, one charger from another. Okay, a typical charger doesn't communicate a lot with the BMS. Once it hits the charging voltage, it goes to CC and CV, done. Smart charger, on the other hand, can communicate with the BMS. It can adjust the CC, CV up accordingly and complete the process. So far in the video, we have discussed CC, CV protocol, charging currents, connectors, what makes a smart charging system. Now, how do you recognize a good e-bike charger? What do you want to see in a good e-bike charger? Let's take a look. So how do we recognize an excellent e-bike charger? First and foremost, safety. How do we look at the safety component of a charger? Well, you want to make sure the build quality is really good. And if you look at the front side of it or the back side of the charger, you must see some of these markings, either UL or CUL or Intertech or TUV. You want to see one of these. And the other label, which is CE, is not that important because CE stands for Conformity European, and this is a label that any manufacturer can put it on. It's a voluntary declaration, but doesn't mean that they have passed all the testing. But if you have CUL, UL, Intertech or TUV, that means you have gone through some of the testing. So you want to make sure it has passed some of these tests. And second importantly, the quality of the e-bike charger is predominantly dictated by the electronics used in it. And sometimes, this is really not up to the end user, but you still want to do some research that it lasts a long time. How do we do that? Well, if the pack or if the charger is guaranteed for 3 to 4 years, that means it's decent. A good e-bike charger, most of the ones on the market are rated for 2 years of warranty. But if you have a charger that is warranted for 4 years, that means the manufacturer is confident. So there's some kind of a confidence in this product. Power density, right? Power density dictates how compact your charger can be. A good e-bike charger may have a power density of 0.25 to 0.3 watt per centimeter cube. Some really high quality chargers can go all the way up to 0.5 watt hour per centimeter cube. But this power density factor gives you an idea how compact your charger can be. And you want to make sure, your charger is compact, silent, it works well, has a long warranty, has all the safety standards. Then you can be fairly certain that, it's going to, do its job fairly well. So far in the video, we discussed about CC, CV charging protocol, how it affects the charging process. We discussed about different charging currents, 2 amp, too slow, 6 to 8 amps, too fast, 4 to 5 amps is the sweet middle ground. We discussed about different kinds of connectors, DC 2.1 for 2 amps, you want a 3-pin for higher currents. We discussed about smart connectors, smart chargers that communicate with the BMS. We discussed about safety standards because it's really important. Now, one tip I would give you is you want to connect the charger first to the wall outlet, then to the battery pack, just to avoid any electrical stressors. So I hope you found this video useful. If you want to learn more about such content about controllers, motors, e-bikes, feel free to subscribe to our channel. We'll be putting out more content in the coming weeks. We are here to serve the e-bike community, and if we earned your trust, feel free to subscribe to our channel, and I'll see you in the next video.